Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 170. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. And Q4 is total waviness of numbers in range 2. I think I actually went over this very recently on the contest before this. So I don't know, it's kind of funny because it is just digit DP. The reason why I figured out it was digit DP pretty quickly, even though it took me a long time to implement, we'll go over that, is that the numbers are big, right? But it only has 15 digits, 15 base 10 digits. And it is just a counting thing. And that you're able to do this one at a time. Okay, so the first thing that I would say is well, let me bring up the drawing board, and this time let me actually put it on screen. Okay, the first thing to notice is that you want to get an inclusive range between two numbers, right? And this is the way that I think about it, it's like you can use the same idea as a prefix sum, because basically the range, right, is that you want to get let's say 120 to 130, right? So maybe you can write something like let's say we just have f of 120 plus f of 121 plus f of 122 plus ... right, all the way to f of 130, right? That's kind of what we're trying to do, right? Well, if you're able to, and this is the same idea as prefix sum, though I didn't leave myself enough space to make it seem that way, is that you have, well, we have f of 1 plus f of 2 plus f of 3 plus ... plus f of 130, and then now you have another one that is f of 1 plus ... I'm gonna ... it to f of 129, or sorry, 119, right? If you kind of have these two together and then you subtract this one from this one, then that's where you could get f of 120 plus ... f of 130, right? I'm not going to harbor this point too long. This is a hard problem. This is how the structure between a prefix sum. So it's something that you really should know before tackling hard problems in general. Okay, so that's part one. Part two is kind of thinking about digit DP, right? And this is a kind of a very tricky one, but the idea behind digit DP in general is just that we are brute forcing, right? We're brute forcing one digit at a time. So let's say you have 150, I don't know, I'm just writing random numbers. Let's say you start 4, right? So you have a 5-digit number, and you're trying to get from 1 to this number, right? I don't know how that is an arrow, but and why we start with 1 is what we said in the first part, right? Prefix sum. Okay, so then the idea behind brute force is, you just try to figure out how to brute force one digit at a time. For example, the first digit, what can it be? Well, it can be 0, 1, 2, 3, 4, right? Because if you try to go 5, then you already know that no matter what the other digits are, this is too big, and therefore it is not within this range, right? Straightforward to understand, hopefully. So only 0 to 4, and okay, and here, I mean, we'll skip the rows for now. I'm just going over the enumeration portion of it. These these 4 numbers, everything can be in between. After that, it can be any other number, right? Or not any number, but all the possible numbers. For example, if 0, the second digit could be 1 to, I could be 0 to 9. 1 could also be followed by 0 to 9, and so forth, right? They all could be. So, and of course, even just noticing that means that there's a sort of a shared state going on, right? Okay. And this is like a prefix, a digit DP structuring, right? However, for 4, this is not true because it can only go up to from 0 to 5, right? Because if it goes to 6, then now you have 4, 6, ... and this number is too big, right? So we can only go up to 0 to 5, right? That's pretty straightforward. That's basically the idea of looping one at a time. A thing to notice is that, well, in this case, yeah. So how do we count? There are a couple of things that you have to think about, but it kind of comes together in how you want to construct the recursion, right? But this is kind of the core part of digit DP. And once you kind of have a good understanding of it, you can kind of slowly, in my case anyway, very slowly grind it out. Okay, so for this particular problem, you're trying to think of peaks and rallies, right? And what's a peak? Well, peak means that if you have a number x and you have a number y and you have a number z that you're trying to, right now, y has to be either the biggest number between these three numbers or the smallest. So to me that to me that means that we have to keep track of two numbers, right? The previous two. Because then now, if we have the previous two digits, then now we can brute force on Z, right? The same way that we talked about, following these rules that we already kind of do for other digit DP, which we talked about. Because then now, let's say we brute force on 1, we have 1 and the last digit is a 2, then now you can still go from 0 to 9, and you should because it continues. But if this is, for example, a 0, then that means that this 2 is congrats, will give you a 1 on your answer, because now this is a wavy peak, a peak of a wave or something. I don't know. Whatever. You get the idea, right? So it gives you a contribution of 1. Or does it? Well, it turns out, and I kind of took a long time on this, this 2, what is its contribution to the answer? Well, the contribution to the answer for this 2 is actually, well, depends on the number of digits left. Because here, let's just say we have 0, but we have now 2 more digits left. Well, these 2 digits, and they're not the same number. I just wrote X as in like as placeholder. But these 2 digits, right? These 2 digits have no impact on this answer, kind of. But it does. I'm saying it weird. But what I mean is that given these 2 digits, this peak will appear 100 times because they're 2 digits, right? Because it doesn't matter what this is. Let's say this is a 5, this is a 2. Well, we have to add 1 here. If this is a 6 and a 2, you have to add 1 here. And of course, given 2 digits, this has 100 possibility. You can also simplify it to or 10 to the, let's just say D for digits, and that's kind of the idea behind this one. I think that's one of the tricky parts that I didn't really that took me a little bit not even come up with. I think once I realized this, it's easy to solve, right? But it's just that I was getting the wrong answer and I didn't know why, and I had to really come up with the test case to kind of construct it to come up for me to discover this. One more caveat though is that let's just say you have, this is the prefix, right, version. So you have 4, 5, and let's say you have this is not a good example because this prefix. All right, let me swap this a second, and for example, you have 495, right? So that means that this is 495. If this is what our brute forcing is, well, what does the last 2 digits can be, right? Well, this is actually not 100. This can, because of this prefix, because the prefix matches the 495, matches 495. This means that this can only go from 00 all the way to 62, meaning that there's 63 possibilities. And that's it. I mean, everything else is the same, but that's kind of the... man, I have a sore throat, so my apologies for whatever, but yeah, but that's kind of the only thing that's different about this one for me anyway, to kind of play with and come up with, which I think is kind of cool, to be honest. A decent problem, but that's basically how I do it. I'm gonna go over the code real quick. Let me cough just a little bit and drink some water. Hang on. Where did my water go? Oh, it's right here. Okay. Yeah, I mean, I talked about the... Actually, I missed an edge case that I didn't talk about. But I thought I would talk about it later. But but I think I just... you couldn't fit it in. But just to kind of... Another edge case, of course, is the leading zero. Right? Because basically... I mean, it's not a big edge case. But let's say you have this number. And you have a 0. Right? And you have a 0. And you have a 5 now. Well, if you have a 2, you just have to make sure that, well, the 5 does not, oh my throat. The 5 does not count as a peak because this 0 is not a real 0. It's a leading 0, so it doesn't actually show up. So you just have to be careful about that. Oh, you have to handle it, that's all. Sorry, friends. Maybe I gotta stop doing videos until my throat heals. But yeah, that's basically it. I'm not saying this is a easy problem, because it's not. But I think once you have all the components, you should be able to solve it. Maybe it takes longer, but you do. This is a digit DP problems. There are easier digit DP problem, including even say the one from that. But the previous contest, I mean, that one was just a medium, right? So definitely practice those first, and then because even this took me a while, but I'm also very out practice. So I don't know. Even though I just solved the other one, but I don't know. You tell me how you feel about this. But let's go over the code. Okay, first of all, we did the thing that we said, right? We did the... Oh, I have to close my fridge. It's like, why is it so cold? We have to do the prefix sum e thing that we said, so we just subtracted. I mean, so we just have to call the function twice, which is fine. And this is how I always set it up, usually. 60% of the time, 100% of the time I set it up. I don't know. Anyway, so this is the string, this is the n. We run out of digits, we go to 0. Keeping in mind that this is the Waviness contribution, not like the number of char or anything like that. We start with a total of 0. If it's and these are just like kind of, you have to think through it a little bit. Sometimes it's tricky, but yeah. Otherwise, if we use a 0. If this leading 0, we use a 0. I marked the -1 as... Oh, yeah, sorry. So we have the index, we have the leading 0, whether we are still, we have currently used a digit yet, a real digit yet, maybe you're going to know what I'm saying. You have whether... How come it's not letting me highlight stuff? Is my computer weird? Anyway, whether we're still matching the prefix, which leads to different situations, and then just the last 2 digits. So the 2 digits that go last, and then the last digit, right? Okay. And once we have that, the index, ran out of digits. There's no more contribution. If it's a leading 0, there's no contribution, of course, because it's a leading 0, and we just keep things at -1, -1. -1 is just the way that I mark it. We add checks later. But yeah, otherwise, if the prefix is matching, then we do a bunch of stuff. Basically, we just kind of sum up. We move first from from 0 to C. If we have a leading 0, we just kind of skip this. If not, then we can use it. Otherwise, we add a check for the sum, right? So we remember the last digit we are adding is I. So now we check the last number and the last two number and see if last is the peak, and last is the valley. So if either of them is true, then we increment the score by 1. Of course, like we said earlier, it depends on how many digits are left. If there are more digits left, then you just have to kind of adjust for those. That's how I call it score, but it's really the contribution of the waviness. And then and you do recursion and you add the score to it. And then this part is the same exact thing, but this is with the prefix match. Keep in mind that C only goes up. It goes up to C minus 1, right? It does not include C. So then, and all of them has the prefix not matching and no more leading zeros. Shift the last to last 2. I as the last digit, and that's it for this part. If it still matches the prefix, which means that the current digit we're adding is C, we just do a check for C. And then this is what we were talking about with the substring. You just kind of do the last couple of digits and try and then add 1 to it, because, for example, if the last 2 digit is 62, it goes from 0 to 62 inclusive, so you have to add 1. So that's basically the idea here. And of course the prefix still matches, but no more leading 0. We shift the last 2 numbers, and that's it. And if the prefix does not match, then we just try every number. This is basically the same logic, except for this is false for all of them now. And that's it. We kick it off. We're happy. We're okay. And what's the complexity here, right? Well, this could be at most 15 digits, so index goes up to 15. Leading zeros is either true or false. Prefix is either true or false. Last 2 is either -1, I guess, but also 0 to 9. Last is also the same thing, so this is 11. So 15 or so times 11 times 11 times 2 times 2, it's going to be fast enough. And each of these, we multiply it by at most a loop of 10 operations. And so that's going to be fast enough, and we're pretty happy. And that's it for this one. Let me make this slightly smaller so you could see all of it. Well, I mean, you still can't see all of it, but I'll scroll down in a second. And this is kind of a little bit verbose. You can probably use the helper function here for sure, but I was just worrying about getting it right. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve a live in contest now. Early on. Alright, wasn't that bad. I mean, it was pretty tough actually, but okay. Anyway, Q4, it seems like it's probably the same except for here, right? So this, we probably need DP. Digit DP, is it? Probably. Right? Yeah, digit DP sounds right. Right, something like that, right? Have a number. Okay, yeah, fine. So then now you have an f function at the index, you have leading zeros, you have the prefix, and maybe the last digit, right? That should be good. Maybe that's 15 times 2 times 2 times 10 should be fine, right? Yeah, I mean, this seems pretty straightforward, really. But, no, I mean, I have to be a little bit careful. Actually, maybe that's not quite. I was thinking about more wavy and like, but this waviness is not what I think about wavy. Is that we're just trying to count the peaks and valleys. It's still gonna be digit DP, but I have to be a little bit careful. This is insufficient. So I can maybe have a thing that defines maybe a variable or something that's like the okay. Let's see. How do I want to do it? The last number? Do I just do it 2-digit numbers at a time? Maybe that would work. No, because you still have to be careful. Because you could have a peak next to a valley. So that's where you have to be careful. Right. Okay. I guess just having 2 numbers is fine, right? Maybe. I don't know. I don't know if that's true, honestly. Let's try it. How much time do we have left? Hour 13. I think we're doing okay. I mean, it's not. How are we doing comparatively? Okay. Wow, people got killed doing much faster than I did. So I don't know, but I think this is good enough though. But just annoying to write. Okay. Right. Now if leading 0, then we can just keep on doing leading 0, right? So f of put another 0. True. Prefixes shouldn't matter, and then I mean, this should be all leading 0s anyway, so doesn't matter. Okay, and then otherwise, if we have to care about prefix, then the current is equal to s sub index, right? Then now for I in range from 0 to C, not inclusive, of total index plus 1. Obviously force, prefixes to force. You have last is the second, and then I, right? And then you have to do some checks to see if it gives you a thing, right? Add check for some, and then now false true, also last C, something like that. But you have to also It should be okay, I think. You have to also add check for sum, and then we just return total. Otherwise, if it's not prefix, and this is even easier, and it's literally just this, right? Am I done? I mean, I'm no, but am I close to done? I don't know, actually. This part is going to be tricky. -1, maybe. Should be okay. I think as long as these two numbers are equal, it should be okay. So then now, if okay, so I mean the leading thing. I'm just going to put it for consistency, but score is equal to 0 if last 2 is less than last, and last is greater than 0. You know, they should be -1s, so whatever. Something like that, right? And I think that sets a template for us. I have to also change it for the other way as well. Oops. So this one should still also be not possible for this one, but I guess now I can do it this way. I could just copy paste. And this is going to be I. Right. This is C. This is back to I. I'm going to add the score. Maybe I should write this template a little bit differently. It's not a template, but I remember the cache. I do. I mean, -4 is probably not right. Right? But how do we have 4 examples? Did I put that in? Oh no, here it is. And then 3 examples I meant. But okay, I mean, it works for the last one, which is nice. But not so good for the other ones. -4 is pretty bad. Can I do something weird? Gonna do weird. I mean, maybe it's just handling of this. Yeah, that doesn't even, like, it shouldn't, it cannot both be true, so I don't think I need to try that. But is it prefix? Yeah, and I have, okay. So 45 here, which means that it sums up all these other things, right? Why does it sum up all the other things? Like, I don't think that should happen. Do I reset it somewhere? Or not reset it somewhere? No, the score is fine. So do... I mean, I'm clearly doing something weird. I'm counting 0 twice, possibly. So that's actually a thing. That's definitely not right. I don't know how to fix it though. I just changed that for now just to see what I get. And what I get is I print too much stuff. And it still seems to print too much anyway. For now, I don't think this is, or I don't think this is right, but it should not be this wrong. So let's kind of see where I can. Okay, index of 1, no leading, no false, right? So it's gonna be the 2 digits ago is -1. The last digit is 0. So then that's 1, 2, 3, 4, 6, 7, 8, 9. So 0 is bigger than -1, right? So any number it puts, it should have 0, right? Did I mess this up? Last is bigger than these two. Why? Why is... Okay, let's see again. 2. Okay, so then the last digit 0, 0 is gives 1. 0, 1 gives 1 because it could be 0, but you're already on the second digit. So 0, 1. Oh, because it counts the leading 0. Okay, so this should not be, because it's the leading 0 should not count as the thing. Okay. Okay, maybe that's why. Okay, it's putting way too much. Is it a little bit better? Let's skip this one, -1s. And this is just not possible, so let's just delete this part. Still putting too... I just want to see what my answers are. But it's putting too much. Okay, so it's still giving me 6 and -40, so that's no good. Even though we did make some changes. Well, maybe this didn't do anything, which maybe is true too. I guess let's try something more basic. 120, 120. That give me 2. Okay, I mean that's good for debugging, right? But this is the same issue. That's why, because when I put -1 here, I have 1 here. Then now it tries to do it, but you need a better number than this. Can I just use none actually? Is that true? I don't remember. Oh, okay. I thought there was like thing that makes it like because the problem is that I don't now use a good number for this. So then this is always without doing a lot of if statements on last. Okay, I mean I guess maybe that's what I just need, right? If yeah, whatever, it is what it is. You have to let's see if this works. If it's ugly but it works, then it's not ugly. That's not true, but not that ugly. Okay, right. I mean, I kind of knew that was the case, but I just kind of isn't it like a bun or a reset? Okay, I still have too many print statements. Oh, I could just use this. One is 3, 3, 2. So maybe that's all I needed. I just needed an if statement. Okay, that's YOLO submitted then. Actually, this never even prints because it was underneath. But okay, let's see. 332. Let's actually submit this on Q2 first. Okay, I mean that's good. This is wrong answer, so we waste one here. So actually, let's even edit it in here. I mean, I could see why this is wrong. There's probably some like weird things going on here. I mean, this seems like a good edge case actually, but why would I give 45? 45. It's something like, I don't know. Okay, well let's double check which one it is actually. No, you have to use this one. So okay, so it gives 615 and 570. Where's the actual answer? Let me open another tab. Because we had the right answer, right? So I just want to see. What this was. Oh, I guess I could just write it as 525. So neither of these are right. There's something weird in the way something is going on. Are these numbers right? Did I just get lucky with the deltas or something? I don't know, because it should be matching, right? Like 1 to 130. It doesn't even match on basic numbers. This is not good. And it's a good thing that we practice this. It's gonna be 12. But I put 57. 57 is definitely not right, actually. Because I think I miscount. That's crazy that 900 cases is right, though. The reason this doesn't make sense is because there's not that many numbers. Because it only matters for 3-digit numbers, right? So there are only 30 possible 3-digit numbers. So something's really wrong. So we're just really wrong. Okay. At the very least, we're counting leading zeros in a weird way. Oh yeah, we didn't get rid of this, did we? So that could lead to an issue. Okay. Let's just start with 1, I suppose. not leading. Maybe I should write it here then. That should be fine, right? I think maybe that's... Oh, that we solved the 12.9 thing. 520. So this is way more correct. The funny thing is that I told myself that I needed to do that, right? But I just totally forgot. Okay. I mean, this is wrong. Well, something's wrong anyway. But I mean, a lot of things are wrong. But at least it seems more consistent. Wait, what am I doing? One 248 is gonna be 5025. So that's not right, actually. Right, that's the one that I was looking for, but it was off by so much now. 1 to 1000 is 525, which is right-ish. I mean, this is actually 0. 999 is 525. So we have some other weird things going on. How much time do we have left? We have 51 minutes. Okay. Did I handle the leading thing right? No, because if it's leading, we already used this. Right. What am I undercounting or overcounting? Well, here I'm undercounting. Here I'm just wrong. This one actually is correct, I think. For 999, because 1000 isn't 1, so that's fine. But 1000 is wrong. Why is 1000 wrong? Let's see. Okay, let's see. It's 1000, we have 4, we have 0, 0, true, negative 1, yeah, okay, so prefix is true. This is 1. Okay, it's leading, it gets skipped anyway, and it does all this stuff. Let me say it skips the first digit, it goes true. The prefix should no longer, the prefix should no longer be true. Whoops, okay. I just didn't really think through it. Okay. This is again better, but 4848 is wrong. Right? 4848 should have 2. So it doesn't double count. Or it does not double count, but this number has 2 peaks, so it should give me a 2, but it only gives 1. This is 45 is also... Is that right? I don't even know. What's the test case? Oh, 1000. 1000 should not be 45, so that's also wrong. But maybe that's fine for now. Okay, well, we still have to figure out 1000 then. 1000 is still wrong, because 1000 is still should be 525. Now it's overcounting by a lot. This should fix it, but it's overcounting by a lot. As a result, is true prefix. So that means that this is using a 0, so now it's still leading 0. Okay, I was gonna add a leading 0 here, but it okay. What am I doing wrong? Okay. So if it's 1,000, leading 0, Yes, this is gonna be a lot. So I double count it here. I 0, 0, and leading, then we skip. Yeah, that sounds right. Because we already used the leading thing here. Alright, but then now. Okay, but wait, but it's leading, then the next number, the prefix is false. It does leading again, but also, oh, this double counts because now it has a thing, right? So I have to do the same thing. Just okay. I forgot to look at this part because this part usually is pretty straightforward. Okay, 525, 525. This is actually good because 1000, 1000 is right. This one is not right though for 48, 48. Right, 48, 48. Why does it give me? Look at this one wrong. This is leading, this is prefix, this is last, this is I. Greater than 48, 48. Do I not count the last number or something weird? Let's see. 1 to 48 has 5020. So this isn't even that close, really. We're missing by a lot. Maybe and it starts with the 4-digit numbers, so maybe that's why. I just don't do double, like I'm undercounting something on the double digits or double the, or when a number has double the things. Why? Okay, let's say it's 8, and now you're trying the thing. I don't get it. And I don't know if the printing helps anymore. Okay, so we do have the 3-digit, well, I guess for 1000 not 3-digit, but I just do say 2000, right? That has a lot of 4 numbers. 25. 1148. So we're undercounting that for sure. 4-digit numbers, like 1212, for example. But why? I mean, C could be 0. What happens if C is 0? This gets skipped. This happens. Which is fine, I think. The last number doesn't add anything, right? Am I missing a digit? Why, man? Why am I missing this? Why am I missing? Okay. What is the first one? 1010 is the first one, right? So let's try 1010. The first one with two numbers, I guess is my point. 527, 527. So I guess we're good there. Let's just do. It's gonna be 2, right? 2. Okay. But this one should be right then, right? Huh. Then why am I off by so much later on? What's the next number? I guess 20. Why is not letting me edit? Oh, is that? Okay, fine. Also 2. Then what am I off by? If this works, it works. So what am I off by? This is annoying. I don't know where my bug is. Uh, 991. Okay, so we binary search this to see the first number in which it doesn't. I mean, it is what it is. Sometimes you just have to, I don't know, but it's just something silly too, probably. Okay, so, yeah, still not right. Did I run it? Okay, 671, 590, so still not right. 592. Wow. Am I putting in the right input? No, it's right. So it was very close then. Didn't I had that to be right, or am I just confused? Or maybe I just don't sum it correctly. Maybe I'm doing something weird with the summing. Because number to number, that was right. Right? Maybe? No, 1000 was right, right? Am I confusing it? 1000 is right. Yeah. Well, no, 1000 was right. I just kind of had different inputs. But now 1015 as well. Am I misunderstanding something? Oh. Oh, I see. I'm not multiplying, right? Because I was thinking that, at least the way that I set it up, I need this to be a multiplication. Oh no, how do I do that then? Then maybe my thing is wrong because I was thinking that this gave me a 2, but actually this it's not a valid whatever, but it still gives me a 1, right? Because of this 0, and I do not count that. And then so forth. So that's why I'm missing by like 5 or whatever, because I'm not. So this 1, that's not so bad. You just have to do the math on the number of digits left, right? Because everything as a suffix doesn't even matter. all the suffix has all these things, and then we just have to do it that way. Okay, so it was a misunderstanding of what. Yeah, it was a misunderstanding, but I think now I get it. So then now it just has to be shifted by 10 times the number of digits left, right? The number of digits left is maybe something like this. I mean, I'm just kind of guessing it right now, but and I have to rewrite it because this looks terrible performance-wise. But let's see if it works. 536 now for 1015. Maybe I'm off by a little bit. 532, 527 plus 5, yeah. So what? How did that happen? Oh, why is it off by that? That doesn't even make sense. How many digits are left? It's going to be index n minus index plus 1. Is the number of digits left, not including this next one, right? So it has to be minus 2 maybe. Yeah, I was worried about having to do that check. I think the idea is right, maybe. What was this? 4848? What was 4848 again? Oh, this should be 2, so that's wrong. Oh yeah, maybe that gets fixed by stuff like this. I didn't really think about it though. How many time to 20, 36 minutes? I should be able to figure this out though. Maybe I'm just not being consistent somewhere. Okay. So here we did this digit. So this contribution is going to be, is that right? It should be right? Roughly speaking. Why is this wrong actually? All right. Oh, this should not be 11. 525 is right, and then it should be 527. So why is it 11? Because one of the ones got multiplied by 10, I guess. But which one? Because the prefix is handling. Prefix is wrong. That's right. That makes sense. Because this is, I mean, we have to do a multiplier, but it's not this number. It's the number of suffixes, and the number of suffixes is just the int of s of something like that. That make him an everyone. Yeah, okay. Yeah, just hacking it for now to see if it fixes it. No, unfortunately that didn't fix it. Because that's the count of the number of things remaining. No, but it should have at least have 1, right? So I think that's where this is wrong. Okay, well. Maybe, this is such a hacky thing now. Okay. I mean, this is still wrong. Because 110, 110 should be exactly, so it goes all the way on the prefix here, right? It goes 0. Right, so when it goes to 1, oh, it's just this plus 1, I think. Because it counts the 0 all the way including that number, so it's just this plus 1, actually. So it's this. Alright, looks okay. I don't think 1015 is no, is it 532? Actually, I think maybe that is right. Let's put on the other one. Oh, I guess I already did 532, so I think that is right. Okay. Well, the beauty is that we're still on Q2 inputs, right? So we can just YOLO submit for free. Let me double check. Yeah, okay. So we could YOLO submit for free. Looks good. Now we YOLO submit to Q4. I guess it's not YOLO anymore. But yes. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and all these problems. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.